Okay, this is a video on finding an inverse of a piecewise function. And before even doing that, one, I want to make sure it's invertible and passes that horizontal line test. So also in order to find the inverse, I remember domain and range flip. So it's important to know the range of each piece. So I'm going to start off by graphing my inverse here. And to do that, you always start by plotting the restriction. So if I plot on the top one, if I start at -1, when I put in -1, the output is 1. And let's put in one more value. If I put in 0, the output is 3. So this piece has a range of y greater than or equal to 1. Okay, so now let's do the second piece. So again, plugging in -1, and it happens to have the same output, so this of 1, so this will be a continuous graph. If I put in -2, the output is 0. So this one is looking like this. So with a range of y less than 1. Okay, so now let's, and this first graph should be a little bit steeper than what I drew. All right, so again, so 1, 1, and it should look a little bit steeper than the other. Hard to tell. They have different slopes. The 2x plus 3 should look steeper than the x plus 2. Shouldn't look like one continuous line. Anyway, all right, so to find the inverse, now again, I put those range values because that's very important in finding the inverse. So to find the inverse, you find the inverse of each piece, the same you found an inverse before. So to undo 2x plus 3, remember we first multiplied by 2, and then we added 3. So to do the opposite or undo that, I'm going to subtract 3 and divide by 2. And now the restriction is the range of the original piece. Okay, so now let's do the second one. The second one, the first thing I did, or the only thing I did, was add 2. So the inverse would be subtracting 2. And again, the restriction is the range of the original piece. So that would be your inverse.